Here we have what's called a related rates problem. We'll discuss why it's that type of problem in a moment, but let's take a look at it. Casey left her bicycle 8 feet from a wall. So here's Casey's bicycle, here's the wall, and the back of the bicycle is 8 feet away. If the top of the ladder begins to slide down the wall at a speed of 4 feet per second, so the ladder is sliding down the wall, which means that the bottom of the ladder is getting closer and closer to Casey's bicycle. What is the speed of the bottom of the ladder when it actually hits Casey's bike? Well, we're going to need to introduce some variables in order to make any sense of this problem. So let's see what we have first. There's only one rate we're given here, and that's 4 feet per second. And we know that the ladder is moving at the rate of 4 feet per second. So there are different ways to think about that. You could think of the rate from the top here as increasing at 4 feet per second, or you could think of the distance from the ground to the top of the ladder against this wall as something that's decreasing, right? If we have the ladder here, then this height is decreasing. So let's go ahead and call that height at any given point, let's call that y. And y is decreasing. So we see that y is decreasing. And what's happening to the bottom of the ladder? Well, the bottom of the ladder is getting closer and closer to the bicycle. So here we have this situation, then we might have this situation. So let's call the distance from the wall to the bottom of the ladder at any given point. Let's call that x. Well, we then have a relationship between x and y, but what is it? Well, the one thing that's true is that the hypotenuse, well, we actually have a right triangle here, right? And the hypotenuse of that right triangle, although this may not look like it's to scale, will always be the length of the ladder, which is 16 feet. So we can actually use the Pythagorean theorem, which tells us that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. So we have x squared plus y squared is equal to 16 squared, and that is the Pythagorean theorem. We'll write that out because he deserves some credit. So that's the Pythagorean theorem. Now, how are we going to get these rates into the picture? Well, for that, we need to take some derivatives. So let's go ahead. This is the only equation that we have to work with. So let's differentiate both sides of the equation with respect to t, because time is the independent variable here, and these distances are changing as functions of time. So let's differentiate, but you see that we have to use the chain rule. So here we have 2x, but we have to have dx dt because x is a function of t. And then when we differentiate the y, we get 2y dy dt. And what happens on the right-hand side? Well, the derivative of a constant is 0. Now we're going to go ahead and solve for dx dt. That's the rate at which the bottom of the ladder is moving when it hits the wheel of Casey's bicycle. So we can cancel the 2 from both sides, because if we divide everything by 2, we'll still have a 0 on the right-hand side. So at this point we have x dx dt is equal to minus y dy dt, and that's because we subtracted this from both sides of the equation in order to move it to the other side. So let's see what we have here. Well, dy dt is the rate of change of y, and because y is decreasing, that rate is 4 feet per second, but it will be negative because the quantity y is decreasing. What about dx dt? Well, that's what we want to know, but we want to know what that is at the instant that x is equal to 8 feet. So it looks like we can go ahead and solve for dx dt. The only thing missing here is y. So we have dx dt is minus y over x, I'm dividing both sides by x, dy dt, and let's see what these things are. We still don't know y, but we know x is 8 and dy dt is minus 4. That'll actually help us. Remember, this is feet per second, and this is feet, and y is actually going to be feet, so that these will cancel and our units will be feet per second. So how can we go ahead and determine the last missing link here? By the way, the two minuses will give us a plus, so dx dt will be positive. Well, let's go back to our Pythagorean theorem. We want to know what y is when x is equal to 8. So let's fill that in. We get 8 squared plus y squared is equal to 16 squared, which is 256. So y squared is 256 minus 64, which, if you check, is 192. And so y is plus or minus the square root of 192, but we want the positive square root because this is a length, and that is approximately 13.86. Let's go ahead and plug that in now. We see that dx dt is equal to 13.86, that's now y, divided by, well, the 4 cancels with the 8, divided by 2, approximately, feet per second, and that gives us 6.93 feet per second, and that is the speed with which the bottom of the ladder is approaching Casey's bicycle. Hope she gets it out of the way in time.